Hello everyone, I hope you are all doing well. So right now we will be discussing exact differential equations and how to find its solution with one example only. So I'll be showing you one example only. From our previous topics, we have discussed variable separable differential equations where variables can be separated immediately so that we can proceed directly to direct integration. We also discussed homogeneous differential equations where we test its homogeneity. But what happens if they are not variable separable, nor when the test is done, it is not a homogeneous differential equation? So we can do a second test. And that's the third type of differential equation that we will be going to discuss. So the same as how you modify the differential equation to test the homogeneity, it's just the same with exact DE. So let m be a function of m be equal to m is a function of x and y, and n be a function of x and y also. So if a differential equation of this form, m dx plus n dy is equal to 0, satisfies the condition such that the partial derivative of m, this function with respect to y, is equal to the partial derivative of this function x with respect to x, then this differential equation is an exact differential equation. So I assume that you will recall your partial differentiation lesson from your differential calculus class. Okay? So assuming that you have proven that this differential equation is an exact differential equation, how would you solve for the solution? So the steps in solving exact differential equation is we have the first step, which we have already discussed a while ago, to test the exactness. And the next part is the important part because it will be the solution for the differential equation. So first step is to solve for f prime and f prime prime. What is f prime and what is f prime prime? So f prime is your partial integral or the integral of your m with respect to x. And your f prime prime is the integral of your function n with respect to y. So please observe carefully the difference. To test for the exactness, you are going to get the partial derivative of m with respect to y. In short, our independent variable here is y, while x is considered constant. Okay? But when you do the integration, you integrate m with respect to x. Therefore, you treat x as the independent variable and you treat y as the constant. The same goes with n. For the testing, you differentiate n with respect to x. Therefore, x here is considered the variable while y is considered constant. For the integration, y is considered as the variable while x is considered the constant. So step 3. This will be the overall equation for your solution. F is the union of f prime and f prime prime. So why do I say union? Because there are times where part of the answer of your f prime is the same as your f prime prime. So they have the same terms, and it must be written as part of your solution only once. And then you include the other terms also. So r here is a function of x and y is a similar terms which can be, or the same terms, not similar, the same terms found in f prime and f prime prime. Well, your g of y is a term or terms found in your f prime but not here. And f of x is a terms found in your f prime prime but not in f prime. Then the solution of the equation is f, which is the combination of all your f prime and f prime prime, then equal to c. Please don't forget this. This is not equal to 0, but this is equal to c. That's a common mistake made by students. So now let's proceed with the example. We have here find the solution of the differential equation shown. That is 2y over x dx plus 2 ln x plus 1 over y quantity dy is equal to 0. So what's the first step? Of course, you must modify the differential equation into the form m dx plus n dy. But as you can see, the dx and the dy are already separated. So we can proceed with the testing for exactness. Okay, so our first step here is to test for exactness. Okay, I'll just make this bigger so that you can clearly see. That's what I have observed. The penmanship is too small. Okay, will that be enough? Test for exactness. How do you do that? The condition is your partial derivative of m with respect to y must be equal to the partial derivative of n with respect to x. So listen carefully about this, guys, in case that you have not recalled how to do partial differentiation. So we will partially differentiate m, which is what? What is m? Our m here is the function beside dx, that is 2 over y, 2y over x with respect to y. Now we are doing here partial differentiation as what I've told you a while ago with respect to y. Therefore, y here is considered the variable and x is considered a constant. So you will think like this is a number, this is a constant number. And how do you differentiate 2y over x with x as constant? So if you find it difficult, my technique here is that you just imagine x as a number. So let's assume x is equal to 3. It's just an assumption. You can really make your own. So what will be the derivative of 2y over 3 with respect to y? So what will you do? Of course, you are going to separate first the constant, right? And what is our constant? That is 2 over 3. That is 2 over 3. But what is really 3? Of course, your imagination, x is equal to 3. Go back to reality. 3 is really x. You can really make your own number. 2 over 5, so this is 2 over 5, 2 over x. And what is the derivative of y with respect to y? That is just 1. Therefore, times 1, okay? I won't write that anymore. Therefore, your partial derivative of m with respect to y is equal to 2x. Now, let's proceed with the partial derivative of n with respect to x. Okay, so what is our n? Our n is the function inside the bracket, 2 ln x plus 1 over y. So now we are differentiating n with respect to x. Therefore, we consider x as a variable and y as a constant. Okay, so this would be the partial derivative of 2 ln x plus 1 over y with respect to x. X is variable, y is constant. So if this is variable, 2 ln x, x is considered variable. What is the derivative of that? Please recall your formulas in differential calculus. The derivative of ln x is 1 over x dx. So this is 2 over x, derivative of 2 ln x. Now, what is the derivative of 1 over y with respect to x? Again, y here at this part is considered constant. So if you find it difficult, just imagine this is a number. So what would be the derivative of 1 over, let's say, 2? What is the derivative of 1 over 2? That is just 0. Or the derivative of any constant is equal to 0. So this is plus 0. And I'll just not put that into writing. Therefore, the derivative of your n, this n with respect to x, is 2 over x. So as you can observe, this and this are equal. Therefore, our differential equation is an exact differential equation. Okay? Now, we have tested for the exactness and we have proven that this is exact. Let's proceed with step 2. What is step 2? You solve for f prime and f prime prime. What is f prime? F prime is... f prime is the integral of your m. But with respect to, if this is y here, here is x. Okay? And what is your m again? That is 2y over x with respect to x. So now, what is the letter that we are considering as a variable? Of course, it's so obvious now. We consider x as the variable and y is a constant. So you can really imagine y as a number and what to do when you're integrating 2y, or let's say 2 times 3 over x. So I will separate the constant first, which is 2y. And what is the integral of 1 over x? That is ln x. Okay, so do not put here plus c. We will include c at the last step. How about for f prime prime? That is the integral of n. But here we have here with respect to x. But here we will differentiate that or integrate that with respect to y. And what is our n? That is 2 ln x plus 1 over y. Now again, guys, you consider y as the variable and x as a constant. So if this is a constant, what do you do when you integrate this constant with respect to y? Again, you will separate the constant, and then what will be the integral of 1 with respect to y? That is 2y. That is just simply y. Oh, this is the constant, and the integral of the remaining, which is 1 dy, that is just y. Okay, guys, I hope you are catching up. If you don't, then ask help from your classmate. So what is the integral of 1 over y? We are now at this part. That is also ln y. Now, as you can see, as what I've told you a while ago, there are lots of times when you will have the same terms solved after you solve for f prime and f prime prime. So as you can see, we have here similar terms, or the same exact terms. Correction, exact terms. Our f would be equal to 2y ln x. You write 2y ln x. Then that is our f prime, and our f prime prime is also 2y ln x, but there is a plus ny. So I'll just add 1 here, plus ny. Okay? Now we will proceed with the solution. So I will just put here equals c, right? Now simplifying this, we can combine ln xy and ln y. Again, laws of natural logarithms. This will become ln, I hope you can catch up with this. Is it alright with you? I changed c with ln c. Of course, that should be alright with you. I'm the one solving here. So, sige, let's proceed. I can combine this one. This will become ln y x to the 2y equals ln c. Then I will make that as the exponent for e. And our final answer would be y x to the 2y is equal to c. So actually you can stop here. You can stop here. But I like a simplified answer. So that is our final answer. Ta-da! So thank you for listening, guys. I hope you will practice solving on your own without watching any solutions. Thank you.